Okay, so let's come to the third notebook, which is TensorFlow and Keras. We have already learned about TensorFlow and Keras in short. Now let us take a deep dive. If PyTorch is your go-to, TensorFlow might look unfamiliar, but the tensor operations are almost identical. This notebook is the TensorFlow equivalent of PyTorch tensors notebook. Creating tensors, like you can create tensors using many methods we can see here, like immutable tensors, tf dot zeros, tf dot ones, tf dot normal. The biggest difference from pytorch is that tensor flows are immutable. You cannot assign an index. For mutable state like model weights, you can use a variable called tf dot variable. Data type works the same. Float 32 is your default, float 16 for mixed precision. One thing TF does is differently type promotion. It's stricter than PyTorch promotion. It's stricter than multiplying by a float 32 by a float 64. Will warn you instead of silently promoting. Indexing and slicing follow NumPy conventions. For advanced indexing, TF uses tf.gather and tf.gather underscore nd instead of PyTorch's fancy indexing syntax. Reshaping uses tf.reshape, tf.squeeze, tf.expand underscore dims, and tf.transpose. Broadcasting is the same way that NumPy used and PyTorch. Compare dimensions right to left, compatible if equal or 1 is 1. The bias addition pattern works identically. Linear algebra like tf.lineal or like at sign operator tf.einsum works the same as it worked with PyTorch. Learn it once and use it in both frameworks. Reduction operations are slightly different syntactically. Tf.reduce underscore mean, tf.reduce underscore sum, and with x is argument controlling which dimensions you collapse. These show up constantly in loss computation. The deep learning pattern section implements softmax, cross entropy, and normalization for raw operations. Like then shows the equivalent of tf.one liners. And here's the bottom line: TensorFlow versus PyTorch. The tensor operations are nearly identical. The differences are in mutability, gradient tracking, syntax, and deployment ecosystem. Don't choose your framework based on tensor ops. Choose based on what your teams uses and where to deploy, because both are quite useful. So now let's go through the notebook once again. This is combining the tensors, which is the same way as NumPy does. Element-wise operations, which is broadcasting. Einsum, here are some plots of common activation functions. Broadcasting in deep learning has a big use case, so there's that. These are some vector operations like dot product, L2 norms, eigen decomposition, singular value decomposition, which is SVD, einsum, which is the power tool, and yeah, some reduce operations like sum, mean, average, variance, argmax, argmean. Like we can see that TensorFlow is almost identical to NumPy with some like minor differences. And here are some practical exercises, and here are some summary for short cheat sheet. These are the functions that you can use for NumPy and PyTorch. So yeah, that's about it.